Okay, so I'll start out by saying that, you know, with a class average that was so low and with so many people with Fs, you know, I feel like I need to do something to, you know, help you be more prepared for these exams. But it was also our first exam, right? So you kind of got a feel for it. I really don't want to harp on this too much. It's one exam. I understand it is 20% of your grade, but it's not enough to like completely destroy the semester. So I'm not going to hand these back till the end of class because I don't want you to sit there and go through them, and I want you can take them home and look at them. Right now, I have no plans to change anything as far as makeup, corrections, anything like that. I don't plan on doing that. Now, what I will say is that if you do well on the next exams in the final, I will not let this exam hurt you. But what you need to do is demonstrate in the next exams that this was kind of an anomaly. Like, you know, it happened. It was a bad day for a lot of people. But the best thing you can do for yourself is do well from here on out. And then at the end, I may entertain the idea of replacing this with whatever your exam average is the rest of the way. But your part is to just do well the rest of the way, okay? Let's see. We had 1A, and that was the highest grade, 91.25. 5 Bs and 2 Cs. So we had, 8 people pass the test. We had 19 people not pass the test. That's a huge percentage, like 2/3 of the class did not pass. And this thing, standard deviation, I don't know if you've ever seen that before, but in statistics what we do is we look at your average, but we also look at how far apart the scores are from each other. So I can give you a real simple example. If I only had 2 students in a class, and one student got a 0 and the other student got 100, my class average would still be a 50. But if I had 2 students, one of them got a 25 and the other one got a 75, if I took the average, I'd still get 50. And if I had 2 students take a test and they both get 50s, then the average would be 50. So all 3 of these different scenarios, I have a 50 class average. That doesn't tell me a whole lot. I mean, it tells me something, but it doesn't tell me how close together they were. So like for this one, we would have a very large standard deviation. They are spread out, right? The 2 students are spread out. Here, I would have actually a standard deviation of 0, like it would be no separation between the 2. Does that make sense? So I like to look at the class average, and I would like for that to be higher. I'd like it to be around a 75. But this number is the one I really look at, and this tells me like, it's kind of like, are you all going down with the ship together, or is it just, you know, is everyone kind of in the same place, or are we spread out everywhere? The good news is that a standard deviation of 18% is typical in a class. That's about what I normally get. The highest I've ever seen is like 24, and the lowest I've ever seen is probably about 15, 13, somewhere around there. So this is on par. The problem is everyone's together, but too far this way. I'd rather have everyone together, a little bit moved over, all right? So we'll work on that. I'm going to work on the next exam, trying to get you prepared a little better. We'll see how it goes. Any questions? I know some of you did not finish the exam, did not get to do number 8, and I said you can go home and you can work it out. So I'm not going to allow you to turn that in to affect this grade, but I will allow everybody the opportunity to do number 8 and turn it in for some credit. All right? It's just not, it's not going to be, it would be unfair of me to tell people, oh yeah, you get to take it home, but the people who did it in class had to do it in class. So, but I'll do something with that. Let's not worry about this exam right now. Let's put this behind us just for now, and we will come back and discuss it later. I thought about not even posting the grades and just letting y'all have a good weekend and then coming back on Tuesday and talking about it, but I was like, no, I'll just get the grades in. So these are posted on Canvas. Yeah, so check it out at the end of class, but I'll also hand you your exam before you leave. Okay, today we start functions, and then on Tuesday we start talking about quadratic functions. Today, I anticipate that today is going to be a little bit bumpy, okay? Today's going to be a little rough. That's just historically, even my Calculus 1 students struggle with some of what we're going to do. Now, if you get it, good. But there's some tricky algebra today. And what we're going to look at is something that you will see in the next business math class, the calculus with business, right? Or business calculus. In that class, you will need to be able to do something we do today, all right? It's a mechanical process. It's very important. So when we get to it, I'll let you know, all right? I'll say, okay, this is what I was talking about at the beginning of class. But we're going to start with functions, and I do have some sort of idea that most of you have seen the idea or the concept of a function. So I'm going to go through the beginning of this kind of quick so that we can have time to go through that harder stuff. So a function, I'm going to give you kind of a definition. A function is a rule which takes a number, changes it, and returns exactly one new number. Now, this is not the definition you would see in the book, okay? The new number. I'm tired. The definition in the book is more mathy than this one is. I want us to look at this. A function is like a machine. It takes in a number, does something to it, spits it out. All right, so we like to visualize these. And we usually use these two little kind of egg-shaped things. And we say, okay, a function takes a number in. So I'm going to just list out some numbers, 1, 2, 3. But just keep in mind, it doesn't have to be just 1, 2, and 3. It can be different numbers, all right? It could be all numbers. It could be just positive numbers. It could be just even numbers, whatever. It takes those numbers, it does something to the number 1, and it spits it out over here. Let's say it turns 1 into 2, it turns 2 into 4, it turns 3 into 6. And the actual process, the machine that does this, we call f. F standing for function. Now, can you tell in this problem what f is doing? Does it appear to you like what that f is doing to that 1 and what it's doing to the 2 and what it's doing to just doubling it, multiplying it by 2? That is what it's doing. So we will have a way of actually writing out this rule, okay? We will be able to write out the actual rule mathematically, algebraically. And so for this particular one, we would write this. Let me do this. Let me put in here in a different color. What if we follow the same pattern, then if I take an x, all right, just some arbitrary number, and I send it over here, what's it going to become? 2x, right? That's the idea of what's happening here. So the notation we use for this is this. We write f with a parenthesis, x, and then close parenthesis, and then we would write equals 2x. And the way that we would say this, right, if you were talking to someone, you would say f of x equals 2x. That's how you'd say that. F of x equals 2x. So f of x equals 2x. in this picture, everything over here, these are the inputs of the function. Okay, these are the things that go in, these are the things that come out, right? Well, we have a more technical name in mathematics for the input and the output. We don't call it the input, output. We call it, anyone know what we call this? The things that you can plug into the function? You ever seen this word, domain? Domain and range. Okay? So the domain is what you can plug into the function. The range is what comes out. Understand? Questions? All right, I'm going to draw another picture. I really didn't want to erase that definition, but I need this space. I'm going to draw something else, and I'm going to ask you whether or not this is a function. Let's stick with 1, 2, 3, and let's just go 4, 5, 6. I'm going to tell you that 1 goes to 4. I'm going to tell you that 2 goes to 6. I'm going to tell you that 3 goes to 4. So is this a function? A function is a rule which takes in a number and turns it into exactly one number. So does this 1 get taken or get changed into exactly one thing? Yes, it gets changed into 4, right? Does 2 get changed into exactly one thing? Yes. Does 3 get changed into exactly one thing? Yes. Okay? The fact that 1 and 3 went to the same place does not matter in terms of the rule. The rule says 1 input goes to 1 output. Doesn't care what the output is, it just can't go to 2 outputs.
So if it went to 4 and 6, well, if 1 went to 4 and 6, it wouldn't work.
Exactly. I'm going to give you an example of one that wouldn't be a function after this. So this right here, this is a function. Now, this is a function. Now, in terms of trying to come up with the actual algebraic equation for it, that's going to be hard. Okay, I'll just tell you right now. I don't expect that you could look at that and say, oh yeah, that function is f of x equals blah. Okay, that's a tough one. We actually won't do anything like that, so don't worry about it. Now, let me draw you a picture of another one. And I've kind of already alluded to the fact that this one should have a problem. So let's go 1, 2, 3. Let's go 4, 5, 6 again. So I could create a problem if I take, let's say, 1 to 4. How about 2 to 5? 3 to 5. That's still okay, right? Yes. But if I take 2, where? It doesn't matter where I take 2. Let me take 2. I didn't mean to do that. Let's take 2 to 2 different places. See how 2 goes to 5 and 6? This is not a function. Because you have an input that goes to 2 outputs instead of exactly 1 output. Now that does come into play later, the idea of a function. In this thing right here, it comes in later when we talk about inverses of functions. We need to understand this concept. All right, let's talk about the graphs of functions. Okay, so this time I'm going to give you a function. And then we're going to try and see if we can come up with a graph for it. So let's look at the one that we had earlier, f of x equals 2x. If I was trying to visualize what this was doing, it's taking 1 to 2, 2 to 4, 3 to 6, right? That's what it's doing. Then the standard, like when you're first learning how to graph functions, the standard way to do it is to make a t-table. Have you all seen that before? And what you're going to do is, here you're going to put the inputs, x, and here you're going to put the outputs, f of x. And then you just make like a list of all the inputs and outputs that you don't have, I mean, there's really an infinite number of numbers I could plug in here, but you just get enough to get a feel for what's happening. So we did 1 was 2, 2 was 4, 3 was 6, 4 would be 8. Now how about a negative number? We haven't tried a negative. What would negative 1 be? Negative 2, right? And I could keep going. I could do this for the rest of my life, right? And just keep doing numbers. So what we like to do is we like to look at these as ordered pairs. And what I mean by that is all of these here are different x and y coordinates on your standard xy plane. So if I come over here and draw this like this, what we're going to do is try and plot all these points. Now, what we want to do is keep in mind that the y is really f of x. It's really the function's value at x. So like 1 is the input, 2 is the function's value at 1. Input is 2, this is the function's value at 2. So I put my x-axis here, and the y-axis now becomes this f of x axis. Now you could call it y if you want, and that we usually do, call it y. But just please understand, these are the inputs here. The inputs give us our left and right, and the output gives us our up and down. And if we start graphing these points, the point 1, 2 would be here. The point 2, 4 would be here. And if we continue to do this, we're actually going to get something that looks like a what? What does this look like? If I start connecting these, it looks straight, right? It looks like a straight line. And it is. It's a linear graph. And you can tell because look at the function itself, 2x. That kind of looks like this good old thing, y equals mx plus b. Remember that? We had y, which is really this coordinate, right? The y is actually a number times x plus this was the y-intercept. So in this case, our y-intercept should be what? 0, and then our slope would be 2. But we graph them all, and we get an idea of what it looks like. And we're done. So this is very, I guess, similar to something we've already done because we've done lines, right? But now what I'm going to do is I'm going to give you a picture of a function, and I'm going to ask you to go backwards and give me its values. All right, so I'm going to take a moment to draw a function, and I'm going to have to be somewhat accurate with it so that you can tell where the points are. So here we're going to find values of a function from its graph. So let me draw something. Does every function that you ever draw have to be a line?
No.
No, I just gave, that first example was a line, but functions in general do not have to be lines. So let me make one up here. There's your x, here's your f of x, and I'm going to kind of grid this out a little bit. I'm going to do it very lightly so you can see it. This will help you be able to determine where things are in a moment. Okay, I'm going to draw the function in a different color. This is the middle right here, all right? So how about a function that does this? Put an arrow here. Something like that. Now I didn't label things here, but this is 1, this is 2, this is 1, this is 2, right? And that's the origin right there, 0, 0. Okay, so here's my first question. Find f of 0. So what am I doing here? Yeah, so the input is 0, right? And this is saying what happens, right, when you put 0 into the function. So you have to go to an x value of 0. X value of 0 is here, right? And you want to look at where your graph appears. And that's going to be right here. Isn't it this point right there? What is the value or the y coordinate of that point? -2. Is that clear? All right, how about this one? Find f of, let's go with -2. What's that? 1. Good. So you're saying again, the x value is -2. Go figure out what the y value is. So you move over 1, 2, and then you kind of look up and down, and you say, oh, it hits right there. And look at that. The y value there is 1. Is this making sense? Okay, how about this? When is f of x equal to 0? This is a slightly different question. Do you see the difference in what I wrote here? Right? When I asked this question, I said find f of 0. That's all I wrote, right? Here I said find f of -2. That's all I wrote. Here I'm saying when is the function equal to 0? So I'm asking you, at what x values would your output be 0? Can you see where your output would be 0? At 3? At an x value of 3? Is that the only place? Happens here and here, right? There's actually 3 separate places where your function's value is 0. 3 different x values. So they are -3, right? We agree? -3, what's the next one? -1, and the last one, 3. 3 separate values, right? So the way we write this is we put a set of braces, not parentheses. So your x values have to be one of these numbers. This make sense? It's kind of backwards. This is like a backwards question from these two. Here you're plugging these in for x and you're finding the y. Here you're given the y value and you're asked to go find the x. Questions on this? Okay, I'll give you one more. D. When is f of x equal to -1? This one's going to be a little harder. You're saying when is the y value, right? That's what this says. When is the y value -1? So -1 for our y value is actually right there, isn't it? So we're going to try and find this point and this point, and we're going to try and estimate what x value created that. So this is kind of, we're just going to have to eyeball this one and guess a little bit. All right, so what do you think? What do you think the x value is for this point? -0.5? Okay, I'm good with that. -0.5. You could also say -1/2. How about the other one? 2.5. Are these the only two? No, there's actually another one back here, isn't there? But my graph kind of goes away. So back here, I don't know. What do you think? We can just guess that one. Negative, you could say, well, this one's -3, right? So it's got to be more than that. So close to -4. If you said -4, I'd be okay with that. But the idea is that you recognize it's there, right? So let's just go with negative, I'm going to go 3.75 because it doesn't quite look like 4 to me. On a test or on a homework assignment, you'll be able to tell where the points are. There will be no gray area. All right. So that's how you read a graph and recover function values. Y'all seem tired. It's making me tired. I'm sorry? Is the final exam cumulative? No, it should not be. Because we have 3 exams and then a final. So after the 3rd exam, I believe we have quite a bit of material. Yeah, because after the 3rd exam, we have, let's see, well, shoot, 1, 2, 3, 4, 5, 6, 7. There's 7 sections after exam 3. So I'm thinking the final will cover a lot of that, and then little bits and pieces from the other exams. But it'll be like, 85% new material as opposed to 100% from everything. Okay, let's talk about domains of functions. Domains. Oh, you know what? Let's evaluate some functions first. Evaluating functions. So for this first example, I'm going to define a function f of x equals -3x plus 1. Now that should look familiar, right? This is actually a line, right? If I replace f of x with y, this is a line. So let's just evaluate this at some different values. So first part, what is f of 0? All you're doing here is replacing x with 0, right? Okay, so you can just, I know this seems very basic, but that's what you're doing. And you should just get 1, right? -3 times 0 is 0, plus 1, you get 1. What is f of -2? What do you get when you plug in -2? What's -3 times -2? 6, and then plus 1, you get 7. All right. C. What is f of t? Uh-oh. Okay. Here's where things are going to start getting a little bit bumpy, like I said. Just a little bit, and then it's going to get more bumpy. What's f of t?
-3t.
So the rule is this. This is the input, right? This is the function. So all you're going to do is replace that x with t. That's what you're going to do, right? So it's just going to be -3t plus 1. And that's your answer. If you plug 0 in, it's an actual number, so you can calculate it and get a number out, right? If you plug in -2, -2 is an actual number, so when you plug it in, you get a number out. But if I plug in a variable, then I can't get a number out. Now, if you give me t, right? If you give me t, I'll be able to tell you the answer. I know you're sitting there going, why in the world would you want to plug t in? Like you were plugging x in, why plug in t? But just stand by. Okay, how about this? What's f of 2 plus h?
-6h.
So you're plugging in, you're replacing x in this formula, right, with 2 plus h. This x gets replaced with 2 plus h. So this is kind of like, you have to keep in mind, this is what's given to us. This is our master function. This is what we're working with. And then every question after that is just asking you to plug this in to that. Replace the x. So you said this would be negative 3 and then what? Parentheses, very important. 2 plus h and then plus 1. You must have this parentheses because the negative 3 must multiply times whatever I put in. So if I put in 2 plus h, it's got to be in parentheses. Now distribute the negative 3 through and you will get what? Negative 6 minus 3h plus 1. And there's still a little bit more work to do here. I can put the negative 6 and the 1 together, right? Because those are both numbers. That's negative 5. So we'll write negative 5 minus 3h. Is that all right? You sure? No questions? Okay, what is this then? Still working with the same function. What is f of x plus h? So I'm going to be replacing what with what? X with x plus h. So this should be negative 3, then what? Parentheses, x plus h plus 1. I'm going to show you below this in red the most common mistake I see on this. People will write this. That's what they'll write. So what did that student do? Well, they didn't distribute it all the way, but actually they never did this step. What they did is they said, oh, if I plug in f of x plus h, it's just f of x plus an h. They just throw an h on the outside of this function. That's not what it means to plug in x plus h. All right? That is a common mistake, yes. Not so much on linear functions, but look, I gave you a very simple function to start. We're about to get more complicated with these functions. So now distribute. See, the thing is, that may seem like a silly mistake, but when you're in an exam and it's, you know, a question mixed with all these other questions, you kind of lose yourself sometimes, and that happens. I think like right now, today, doing it here, it's not so much a mistake I see. All right, so distribute through. Negative 3x minus 3h plus 1. Can I combine any of those together? Cannot. Cannot. So that's it. That's our answer. This is it. I know that looks weird, but that's the result. All right, I think I'm ready to move to a more complicated function. So we're going to continue this evaluating functions. I'm going to come in here and erase this and give you a brand new function to work with, and we're going to evaluate it at some different places. And I guarantee you I'm going to trick some of you on this one. I'm going to get some of you, so please pay attention. Negative x squared minus 4x plus 2. There's our new function. And the first thing, part A, I want us to find f of 0. I'll make the first one very, very easy. So what's f of 0? You're replacing x with 0, right? So this is going to be 0 squared. That's just 0. 4 times 0 is 0. So this is just going to leave you this piece right here, right? That's the only thing left. So 2. All right. How about f of 3? Yes?
If we put 3 in, I don't even know if it makes a difference. But when we plug it into x, like for the minus x squared, does it have to be in parentheses?
That's exactly what I was hoping you would ask. And that's why I said this was going to confuse people, because it is confusing. Like when you plug that 3 in, what does it look like? I'm going to write this down. Don't write this down Okay, just watch me for a second. If you plug the 3 in, that's what it would look like if I just replaced the x's with 3, right? Now I put a parenthesis here just to let you know I'm putting 4 times 3. If I just wrote 4, 3, it'd look like the number 43, right? I could put a dot between them, do that also. The question is, what's happening here though? What is this? Is this negative 3 times negative 3? So is it negative 3 squared, like negative 3 times negative 3? Yeah, so this is what you're asking, right? You're asking. So I'm making sure everyone understands that that should be a question you're asking yourself. This is actually not the correct way to write it. You need to put the parentheses around the 3. Because the 3 is what got plugged in, right? And you have to remember order of operations. Do y'all remember me putting this on the board? I don't remember if it was 4 or 2. I asked you in the very beginning of class what the difference between those two were. I forgot to square this one, sorry. What's the difference between those two? This one is negative 4 times negative 4, which is positive 16. What is this? This is 4 squared first, then times negative 1. So you want to look at this right here as negative 1 times 4 squared. And that's going to give you what instead? Negative 16. See, when you have a negative sitting in front, it's like a negative 1. The parentheses make all the difference. So when you replace this x right here, you want to envision that you're replacing that x, but whatever's there is in parentheses. Same thing here, it was in parentheses. All right? So if I replace that x with 3, then I'm going to have a negative, then 3 squared, and then minus 4 times 3 plus 2. So see if that made sense at all, what I just did there. What is this going to be? Positive or negative? It's not a coin flip. We have to understand. It's squaring the 3 first, right? Because the negative is outside the parentheses. So ignore that. Square your 3. What do you get? 9, and then make it negative. So this is going to be negative 9, right? Minus 12 plus 2, which is negative 19. You can see how that can cause issues, right? All right, let me try another one here. What is f of negative 3? So this time I'm telling you to plug in a negative 3. So how should I write this? Negative, parenthesis, negative 3, parenthesis, squared, good. Minus 4, parenthesis, negative 3, and then plus 2. Very good. That's the exact way you're supposed to write that. Now look at that first piece here. You've been told over and over, I'm sure, hopefully, that a negative, 2 negatives make a positive, right? Like minus a negative, make a positive. But you can't do that because order of operations says that you must do exponents before you do multiplication. And if you did these two together, that would actually be multiplication. That's really like a negative 1 sitting there, and you're multiplying it. So you're not allowed to do that multiplication yet. So you have to square the negative 3 first. What's negative 3 squared? Positive 9, right? Negative 3 times negative 3 is positive 9. However, you're then going to multiply it by negative 1. So it's going to become negative 9. Negative 9. What about this one? Plus 12 plus 2. So you get 5. I hope that makes sense. How about this? What's f of 3 plus h? Okay, things are getting weird now. I'm going to replace x in here with 3 plus h, and I better use some parentheses. So what should I write? Negative parentheses, 3 plus h, close parentheses, squared, minus 4, parentheses, 3 plus h, and then plus 2. Okay. Now the fun part. We get to square 3 plus h. How do you square 3 plus h? Is that just 9 plus h squared? Do you just square each one? You square 3, square h? No. You have to do FOIL. Or remember this. This is 3 plus h times 3 plus h. That's what that means. So you have to do this thing. Remember that? So you go 3 times 3, which is 9. Notice that I'm not doing anything over here. I'm actually doing work over here. We call this scratch work. I'm doing this on the side, figuring out what it is first, then I'm going to plug that in over there. So this is going to be 9 plus 3 times h, 3h, plus the inside ones, h times 3 is 3h again, and then h times h, which is h squared. Now that's what it is when you multiply those together, but notice on that we have two like terms in the middle, 3h and 3h. So you could put these two together to be 6h. So you get 9 plus 6h plus h squared. Does everyone agree that that's what that is? And this is just going to replace this right here, right? That's all that is? What's still sitting out in front of it? -1, or negative, right? So watch the way I write this. I'm going to put negative and then in parentheses all of that. 9 plus 6h plus h squared. I've already done the squaring, so that's gone. This is this. Then I still have -4 and then parentheses 3 plus h and then plus 2. And now distribute the negative through. So when we distribute this negative through, everything gets changed, right? All the signs get changed?
Yes.
So we've got -9 minus 6h minus h squared. And then over here, let's distribute the -4 through. So -12 minus 4h plus 2. And at this point, we collect all of our like terms together. So like terms. And when I do this, I like to do this in like a descending order. I like to go the highest power of h first, but you don't have to do it that way. All I have in terms of h squared is just this one right here. So I've got -h squared. Okay, I've taken care of that one, so I like to cross it out. How about h's? -6 and -4, right? -6h, -4h, put those together, you get -10h. And then finally, the numbers, -9 minus 12 plus 2, -19. And you cannot do anything else to that. That's your answer. When you plug in 3 plus h, you get that, right? For that function right here, if I plug in 3 plus h, the result will be this right here. Look, I understand if you're sitting there going, why would you ever want to do this? I get that. Like, this seems weird. It seems okay to plug in a number, but to plug this in just seems like, why? Why would you ever do that, right? So you'll see. I'll show you why. All right, let's do one more of these. All right, I'm gonna give you a minute. I'm gonna give you 3 minutes to see if you can't come up with that on your own. What is f of x plus h? So same function. And I want you to work through all the algebra of it and see if you can come up with what it turns into.
So you want us to put that in for the...
Yes. And then do all the algebra to clean it up. We just did 3 plus h, right? Now you're doing x plus h into that. How many of you were able to get to this successfully without looking up here? Good? Okay. I'll run through this real quick. X plus h goes in, so you have to put in parentheses. You have to square this, so I did that on the side. And when you do this, the technical word for this is expanding this, but a lot of you learned FOIL in high school, so it's FOIL. And then you have your middle terms are like terms, so you can put these two together and get 2xh. So this expression gets, this whole thing gets replaced by that. The negative has to pass through, and then you distribute the -4 through. And at this point, we don't have anything to collect together. There are no like terms. This is the only h squared you have. This is the only x squared you have. You have xh here. Here you have h, but you don't have x. Here you have x, but not h. So you can't put anything together. So that's it. Looks pretty ugly, but that's what it is.
Does it matter? I put negative x squared, and then I put minus hx
You put this and then
And then I
this.
did that, right?
Oh, that's fine.
Okay.
Yeah, the order doesn't matter because you can always shift things around. Okay? This all right? Okay. Now, do you remember me talking to you about 0 divided by 0? Did we talk about that? No? Maybe not. I don't think we did. Did we? Yes? So, do you all know what the formula is for speed or velocity? When you, like if you look down at your speedometer when you're driving your car and it says 60 miles per hour, it's distance over time. It's the distance you travel divided by the time it takes you to travel that distance. So if you drove to school today, you live 30 miles away, and it took you 1 hour, then you would have gone 30 miles, and it would have taken you 1 hour. So I'm going to put something below this or above it. Your average speed, okay, your average speed would be your total distance over your total time. You would have driven 30 miles per hour on average, right? But you're not actually driving 30 miles per hour the whole time, right? Sometimes you're going faster, sometimes you're going slower, you come to a stoplight, right? Understand? So if I were to try and graph your trip to school today, if you were that person, right? Then here would be time, and here would be distance. Then you would have started at 0 time. That's when you're about to leave your driveway or whatever, parking lot. And you haven't gone anywhere, right? And then after 1 hour, you would have traveled a total distance of 30 miles. Which means that you would be here, right? Then, if I were to check how far you were at half an hour, you wouldn't necessarily have been 15 miles away, right? Maybe the first part of your trip, you're on highways, clear sailing, then you start getting closer to school, it's more traffic, right? So you have to slow down. So at halfway point, I'm not necessarily at 15, right? Are y'all following me? Yes? No? Okay, so maybe you're here. And then over here, maybe you're here, and then maybe here you were here. And if I put all these together, I would have a graph of your trip to school, right? A function that shows you where you were at every point in time. So let's say that I wanted to know your average speed on the entire trip. Your average speed on the entire trip would be the total distance, 30, divided by total time, which would have been 1 hour, which we already know is 30 miles per hour, right? That's what we just said? But what if I wanted your average speed on just the first half hour of the trip? What would you do? I would take this distance, right? I would need to know this distance. Where were you half an hour into the trip? And I would divide that. That would be this divided by this, right? Do y'all recognize that? What that is? If I take this distance and divide it by this distance? Isn't that like rise over run? Isn't it? It's how much you rise by how much this went over. So it's almost like we're computing the slope of that line connecting those 2 points. Just like up here, if I take this line coming down, the slope of this line is rise 30 over run, which was 1. But if I only go this one, right, halfway, then it's the rise over the run. Understand? You sure you understand? Okay. So what if I take this picture, I'm going to draw it again. So I'm trying to illustrate something. I don't know if I'm going to do a good job of this or not, but try. So here's the same picture. Here was 1, here was 30. And what if I look at a point right here? I'm just going to call this point X. That's some point in time, okay? And I go up here, and right there, I ask you how fast you were going. What's wrong with that? I mean, what problem are you going to run into? If I ask you how fast you're traveling at a specific point in time, so I say at this exact moment, how fast are you going? Do you see what the problem with that is? What's the problem?
They don't give you a time.
That's right. You don't, at an exact moment in time, there's no time, no time has gone by, right? Right? And so you really can't talk about speed if you're talking about it at an instant. You need some time to have elapsed so that you could travel some distance. Agreed? And that's what Isaac Newton, who is the father of calculus, that's what he was trying to come to grips with, this idea that when you're trying to find velocity or speed at an instant in time, your distance that you travel divided by the time that it takes you to travel that, these are both zeros. Because at an instant you don't go anywhere and there's no time that's elapsed. And so what do we do, right? Y'all understand?
It's like taking a picture of something moving.
That's right. Perfect. That's a great example. It's like you're sitting there, you're running, and then you take a picture. It's like, how fast are you going? I don't know how fast. I don't see you moving. I need to see you move a little bit for me to know how fast you were going. All right. Well, Newton found a workaround. He found a way to get it. And that's this whole thing, f of x plus h, the reason why we're computing it is because we need to be able to compute that to do this workaround. So let me show you the workaround. Do you agree that if I go from x up to 1 right here, this point, and draw a line, then the rise over run would give me the average speed from here to here? Let me say that again. If I put a point at the end at 1 and I connect these with the line, the slope of that line will give me the average speed on this interval. I'm trying to find the speed at that point. So that's not what I'm looking for, right? So instead, why don't we move this point a little bit closer to x? Right? Let's move it a little closer. So I'm going to pick another point over here that's a little closer to x, and I'm going to call it, I don't know, I could call it y, but wouldn't you agree it's this, whatever this number is, plus a little bit? Why don't I say it's x plus h? How about that? H. H is just a little bit more than x. Understand? Yeah? You sure? So if this is, I can't use one here. Let's say this was 3. This is 3 plus something. If this was 5, this is 5 plus something. Yes? And that would give me a point somewhere here. And if I could find the slope of that line, that would give me the average speed on this interval. Agreed? And how could I get an even better approximation of the speed at this point? Get it closer. How could I get it closer? How could I get it closer? What could I do to h to get it closer? Do I want h to be big or small? I'm going to actually want h to get smaller. If h gets smaller, won't this point start moving? Yes? Okay, that's what you do in calculus. In here, we're not going to move the point all the way over. All we're going to do is we're going to try and figure out right now what happens if I try and find the slope of that line. I want to know ultimately what the slope is at x. But what I'm going to do is pick another point that's just a little bit further to the right, and I'm going to try and find the slope of that line. Can anybody tell me what the slope of that line is? What's the slope of any line?